Hi everybody, I'm Tony Yee and at Show IP Interface Brief, and today is day 48 of the 100 Days of Labbing journey. And I was working on my own topology today, which was the 6-shooter topology. And man, I was getting stuck. I was stuck for about an hour just trying to get basic LDP neighbors across a single link, and I couldn't figure out why that wasn't working. This is something that is extremely trivial. It's actually one command you put at the interface level, and it wasn't working. So I went to Wireshark, and I wasn't seeing anything that stood out to me. So I went ahead and did a little separate mock lab just to try and target this issue, and I found something interesting that I think may be just specific to maybe my lab topology or the images I'm using. So I kind of wanted to go over that because I did learn something today. Although I didn't get very far in my lab, I did learn something. It wasn't what I set out to do today. It wasn't what I set out to do with my lab, but I did learn something, and it's nearly midnight, so I want to wrap it up. And that's kind of the moral of the story here is don't stop labbing until you've learned something. You know, every day that you do a lab, you should never walk away from that lab going, that was easy. You should always just keep hammering it out until you work yourself into a corner where you have to learn something to get out. Even if that means stopping a lab to go research and read and watch a video and look at example configs, then come back and execute. Always learn one thing before you get up out of your chair. And so I've learned my one thing for the night, and very, very simple thing. But I did learn it. Now it's in my brain. Now I don't have to worry about learning it again. So let me show you the problem I was facing and how I went about labbing it up to actually prove that there is a problem, and then my workaround for it. So this is going to take a little over 15 minutes to sort of unfold this whole thing. So right here is my 6-shooter topology. I run an EVE-NG. This is the topology I've been working on the past couple of days. This is the standard topology I use when I'm building my own custom labs. And I use this EVE topology to build lots of logical topologies on top of it. This is actually just the physical. So the logical topology that I've been working on is here. Let me pull it over to the correct screen. Is here. So this is the topology I've been working on for the past couple of days, and the specific area that has been giving me trouble, let's see if I can draw on here, is this section right here between R5, R1, and R6. This is going to be multi-protocol BGP, so I'm going to need to use MPLS, which means I'm going to need LDP. So these technologies are going to need to be in this area. So first of all, I have OSPF running over this. This is a PPPoE interface, PPPoE, and this is a regular sub interface. Nothing to it. So this is an entire OSPF area, which is area, I think I called it 15. Okay, and all the loopbacks are in the area 15. No problem. So I come over here to the PPPoE interfaces, and on router number 5, which is our PPPoE client, we do interface dialer. I'll show you at the command line. But anyhow, we put the MPLS IP configuration on the dialer interface on R5. I put the MPLS IP configuration on the virtual template on R1. So R1, let me start erasing out of here. R1 and R5 do form an LDP adjacency, no problem. I come over between R1 and R6. I turn on MPLS IP on this interface. I turn MPLS IP on this interface, which are sub-interfaces. They can ping each other. They can also ping each other's loopbacks, so they have a route to their loopbacks. I'm forcing the router ID to be the loopbacks, and they do not form an LDP neighbor adjacency. So I'm thinking to myself, that's very strange. It's only one command. I don't see what the problem is here. I looked at some packet captures. I didn't see anything out of the ordinary. I don't have a clue what's going on. So I said, you know what? Let me try it on a different router. So I tried to turn on MPLS on the northbound interface on router 6 and on router 2. And again, these are sub-interfaces and no adjacency. And I said, okay, well, that's strange. The common denominator here is router 6 itself. So I tell you what, let me just go around router 6. Let me go ahead and form an adjacency like this. And so I did, and I made a temporary link that went from router 2 to router 5, turned on MPLS IP, made sure they could see each other's loopbacks, forced a router ID, and I could not get an adjacency. So at that point, I'm thinking, what the hell is going on? Why does it work only here in between router 1 and router 5 and not anywhere else? And so when we go back and we actually look at the physical topology between, let's see if I can draw on the screen here. Nope. Between router 1 and router 5, we're doing PPP, OE, and yes, we did get an LDP adjacency. However, between router 1 and router 6, we did not. And that was not using any fancy encapsulation, .1Q encapsulation, and just typical sub-interfaces. Also, router 2 to router 6 did not work. However, they can ping each other, so they do have reachability through the switching environment, no problem. And to actually be full disclosure here, let me draw the actual path. For router 1 to get to router 5, it actually goes like this. Okay? Switch 3 is actually the route for all of the VLANs. So for router 2 to get to router 6, let's see, I'll use a different color. Okay. Only the red one worked. The orange did not work. So the only thing that's different is that between router 1 and router 5 is PPPoE. So I went ahead and built a second lab environment, actually just to test a theory of mine. The theory of mine was that two routers directly connected to each other will form an adjacency, but two routers going through a switch or switches doing trunking will not. Here's my sample topology. I took a router and a router, called it router 1 and router 2. I put two switches. I connected these guys like that. This is a trunk. This is a sub interface here on router 1. And router 2 has a sub interface. And this is a trunk, and this is a trunk. Okay, so we put a common subnet between them, and this is the .1. Here's the .2. They can ping each other, no problem. I configure a loopback here. On each one, we call it 1.1.1.1. We call it 2.2.2.2. And they can ping each other. I'd put static routes for the loopbacks, and they can ping each other. You turn on MPLS IP on these interfaces, no dice. However, we connect these two routers via a link right here, We turn on encapsulation.1q and make them sub interfaces. We turn on MPLS across here. Yes, we get an adjacency. So there is something funky going on when you go over a switching environment. I think this is just specific to either the images or the lab environment that I'm using. So I've tested this theory with the IOL images. In fact, I'm going to pull it up right now. Also, this lab topology that I'm using is built using IOL images. So I'll do a log out, and I'll log in as a second user. Here's my topology here. Actually, these are just misnamed. Can I name it R1? And name it R2. All right, so I'm going to start all of these. I'm going to hop in and configure the switches real quick. I'm going to configure the routers real quick. And the first thing we're going to do, is that one started or no? Looks like maybe no. Let's see if I can start it again. And we're going to try and see that the LDP adjacency does not form when it goes over the switching environment. In fact, let me zoom in a little bit here. In fact, I can get rid of all of those, I think. Okay, good. Excellent. All right, this is going to be switch 1 and switch 2. I'm not going to bother with host names. Let's just get into configuration. Interface range ETH00 to 1. And let's do switch port trunk encapsulation .1q, switch port mode trunk, and do no shut. And then I'm going to also create a VLAN on this switch number 2. We're going to call it VLAN 12 for router 1 and router 2, and exit. Now for switch number 1. Interface range ETH00 to 1. Switch port trunk encapsulation and no shut. Okay, so basically we just took our interfaces that are facing the two switches, made them trunks, as well as the interfaces facing the routers trunks as well. Now let's get on to router 1 and router 2. All right, it's just going to take a moment to boot. I think just so we don't get them confused, maybe I will do a host name. All right, router 1, router 2. All right, interface ETH00. Actually, let me set the host name just so I don't get them confused. I'm trying to race through this as fast as I can. No shut on the physical interface. Then we'll do ETH00 sub interface here, encapsulation.1q, .1q12. IP address 10.1.12.1. Router 1 will be the .1, and router 2 will be the .2. Encapsulation .1Q12, IP address 10.1.12.2. All right, can we ping across the link? We can. Okay, no problem. Let's go ahead and throw our loopbacks in. This is router 2, so let's do IP address 22222 with a /32 mask. Router 1, same IP address 1111, 32-bit mask. And let's go ahead and put in a static route, which will find the router 2's loopback using its interface as the next hop. So 10.1.12.2. And we'll just mirror that over here, no problem. And we'll test that connectivity before we go any further. Do ping 1111, source 2222. Perfect. Okay, no problem. Now let's turn on MPLS IP, and first we'll force our LDP router ID, then we'll turn MPLS on the interfaces. And if this makes a liar out of me, then great. And if it doesn't, then good. That means I've labbed the hell out of this. So let's do MPLS, LDP, router ID, loopback, router ID. What am I doing here? Loopback 0, force. MPLS, LDP, router ID, loopback 0, and force. Okay, next we'll get on our sub interface and do MPLS IP. Come over here, get on our sub interface, MPLS IP. So I'm going to just wait a couple of seconds here. LDP is normally pretty quick. I forget what the hello timers are on LDP. But we would have typically seen an adjacency, especially in the small lab environment. So let's do show MPLS interfaces. Make sure we have MPLS IP turned on. We're using LDP, and it is operational. Let's go on the other side. Do show MPLS interface. Same thing. Do show MPLS LDP neighbor. Nada. Do show MPLS LDP neighbor. Nada. So this is my point. In my topology that I was labbing up, I wrote myself my own objectives, just like I'm working through someone else's lab. And one of the things I wanted to do was multi-protocol BGP, which needs an MPLS underlay, so to speak. And I could not get it up, but it did work over the PPPoE section. So it was very, very, very confusing. So it brought me to this little lab to figure this out. Okay, so this didn't work. Do show run include IP route. I'm going to take out that route. Do show run include IP. And I'm going to force this route to go over our directly connected interface. Our directly connected interface we did not configure yet, so let's go 0.1, no shut, interface ETH01, and we're going to give it sub-interface 100, because why not? Encapsulation.1Q 100, IP address 10.1.100.1. And we'll just sort of mirror that configuration over here. Interface ETH01, no shut, interface ETH01, 100, encapsulation.1Q 100, IP address 10.1.100.2. Just make sure we have some connectivity. Do ping 10.1.100.1. Okay, let's put our static route in. IP route 11111, and a 32-bit mask, and that's 10.1.100.1. Let's go on the other side, IP route 2222, 32-bit mask again, and 10.1.100.2. Now let's see if we can ping across. Very good. So we know that we are using the directly connected interface, because when I trace route across it, it's the only hop in the trace route. Okay, so we already have our LDP router ID set. Our router ID is a loopback 0. So let's go ahead and just turn on MPLS on this sub interface. This configuration is no different than the other configuration we just completed. MPLS IP, MPLS IP, and see the neighbor comes up right away. Now, isn't that freaking crazy? That is absolutely nuts. I can't explain it. You know, I was thinking maybe this was an MTU issue or something, but man, LDP packets are so small. They are so small, like 80 bytes. I know because I just looked. So I don't know what the issue is there. So when LDP sends out its hellos, it's sending it out to 224.0.0.2, which is the all routers multicast. And I'm thinking the switch must be seeing that and not forwarding it out its interfaces. I don't know. I don't have any other explanation. I certainly can't justify it. But this is what I've proven so far. So how do we get around this? Okay. So I tell you what, let's do no MPLS IP off this interface. Our adjacency will fall. And let's put it back the way it was. And so all we have to do is change our route back the other way. So I'm going to do no, and then let's put in our first route, which was, oops. Okay, and our route, which is here, I'm going to remove it. And then I want to configure the other route. Okay, so now we should no longer be using the directly connected link. We should be going over the switches. So let's do a do trace 1111 source from 2222 numeric. And here we see we're using the interfaces connected through the switches. Okay, so I believe we still have do show run interface ETH00 12. We do still have MPLS IP turned on both sides. Do show MPLS interface. It is still turned on. Okay, so how can we get around this? Here's what I found. If we come in here, we do MPLS LDP neighbor, define our neighbor, say targeted and LDP. Come over here, do a mirroring configuration, neighbor 1111, targeted LDP. We get an adjacency. So what that is doing, that is actually configuring static LDP neighbors, right? It's no longer using the discovery. Now, I don't know if that's a unicast packet. I guess it probably is. I tell you what, why don't we go ahead and grab a capture. Yeah, so let's just sort here and do double pipe. So LDP or MPLS. What did I tell you, 80 bytes? So yeah, so this is unicast, right? We don't see anything going to a multicast address like 224.0.0.2, which is the all routers multicast. They look like all unicast packets. I tell you what, let's tear down one of these. And right now this capture, this Wireshark capture that I have running is capturing from between the two switches. So I guess what we should see is a bunch of them sourced from router 1, destined for router 2, but no replies, no answers. It looks like we have 3 in a row so far, right? Nothing sourced from router 2 because I just deconfigured the unicast. However, we still have MPLS IP turned on, so we should still be sending out multicast hellos. So I'm going to start another capture, which I haven't done this before. On router 2, let's capture the E00 interface. Pull up 2 Wireshark instances. And let's do LDP or MPLS. And look, my interface, which is 10.1.12.2, is doing a discovery. It's sending multicast out to 224.0.0.2. Router 1 should be seeing those packets. But it's not. It's not making it there. It's not going over the link between the two switches, which is very similar to the actual lab topology sort of layout that I have in my topology, of which I was trying to troubleshoot. We are seeing the unicast packets coming from router 1, making it to router 2. Those are unicasts. Everything else is multicast sourced from router 2 going out. So again, as soon as we hop into router 2, up arrow and do the static targeted configuration, we get an adjacency up right immediately, and we see our unicast packets. Okay, so that was what I learned today. It got me one step closer to my end goal in my own personal lab, which is not a very complicated lab. It's just a culmination of a bunch of technologies that I just want to stay sharp on. Like I was configuring PPPoE yesterday, and it burned me, man. I misconfigured 2 things. You know, it's just you don't do it every day. So I want to get back in the habit of doing of always being refreshed. You know, as I've been working through these I&E labs, they're pretty good if I keep on them, but if I don't do PPPoE every time, I forget the configuration. And I forget some of the, you know, context-sensitive help, some of the options that are available. And I forgot about the static LDP or MPLS configuration. I completely forgot until I did it tonight. Now I remember. So that is my lesson learned for the night, and that's where I wrap up. Tomorrow night, I hope to be labbing again. I might be working in Google Cloud a little bit tomorrow. Someone was asking me about how to get VMs access to the internet, or I say VMs, but nodes within EVE-NG access to the internet in the community edition, and I have an idea, so I'm going to try it out and see what we can do. Unfortunately, I think it means rebuilding my EVE-NG VM, but you know, it's all learning. Don't get up out of the chair till you learn something. See ya.